Okay, so looks like we are live on YouTube as well, and then we'll get started with the session right away. Yeah, hi everyone. Good evening to all of you, and welcome to the session on overview of CAE industry. And the session is hosted by Decibels Lab, and will be delivered by Tara. So he's our senior simulation engineer uh, at Decibels. Glad to see all of you have the interest to pursue something in the areas of CAE. So it's always good to know what exactly the CAE is and what kind of opportunities are available and what exactly the CAE engineer does in the industry when they find opportunities, right? Because CAE is kind of a well-paying job compared to design or compared to any other areas as well. So, but there are very few people who get an opportunity to work there. So with that kind of an opportunities being there, so it's better that you be prepared and you have the know-how of how the industry works. So for that scenario, so we have arranged this session so you get to know and gain some insights about the CA industry, and as I said before, what kind of job roles are there, possibly what exactly the guys does in the CA work profiles and stuff like that. So I believe it all excites you as well to know and explore how do you or how you can build your best career in the CAE industry. So before we get started, just let us know if you have any expectations from this session, or do you have any specific questions that you want us to be addressed by during this session. Just let us know in heads up if in case you have any, and then we can get started with the session quickly. So anybody have any questions or clarifications that you would like to seek before we start the session? All right, so there is a question. Great, so if you have a query, you have an option to unmute yourself. Neeraj, if in case you have to, you could just unmute and ask as well.
Yes, sir. Am I audible?
Yes, Neeraj, it's audible. Hi.
Sir, I want to know about CFD careers or CAE careers in Formula One or Formula One industry. Means what is role of CFD, or what? How can I approach that industry, because that is very big industry.
Mm-hmm. All right. So CAE and CFD are two different things. All right. To first to clarify. So here we are here today to talk about CAE than CFD. That's a point number one. And as we just you mentioned that it's a very big industry, but at the contrary, it's a very small niche segment as a motorsports or racing. If you say there are 1,000 CAE engineers, I don't think so. There's even one person works in motorsports, right? Because it's a very niche area. Maybe among 5,000 people, there may be one guy comparatively works in, that too in CFD specifically in, motorsports. So keeping that as a limited scope, I think we would not focus much there today. What we're going to focus in general in automotive, and then specifically to gaining an idea on how the CAE is actually being implemented in the automotive industry. Great. So I think we take that input, and maybe we'll look forward in the future that we can align some sessions to your interest as well. Great. So anybody else have any specific expectations that you would like to set before we start the session? All right. So there is Prashant Rawat. I have done only BTech and in ME mechanical engineering, also working in meshing engineer from some months. Does MTech career growth in case of necessary, because I want to analyze? Okay, so yeah, in case, see that today, I think a lot of opportunities are skill based than your degree based. So there are potential possibilities. Let's say you do a MTech in CAE, maybe like that. I know it's not easily available anywhere, but in case that you have some possible potential opportunities, that is more focused like an industry application based a training or a MTech, then obviously it will help you. But if you're just studying another academic syllabus in a typical college as an MTech degree, I'm not sure it's really going to help you. But though what happens is when you spend some time with the subjects and syllabus during being there, and you may strengthen your basics a little bit, But yeah, you better find a right college that has a right curriculum, and so that it meets and exceeds the requirements of the industry. Maybe like a live projects or live examples and taught by some experts who has worked in the industry and stuff like that. That may help you if you're already meshing engineer. And we also have some courses on our platform, like in continuation to meshing to analysis. You can possibly explore there as well. So, but in general, it may not be mandatory, but though, yeah, if there is a college that supports you to that level, you can definitely explore. Great. So cool. Then I think great and good to see people's interest pursuing it being here. I believe that's all that we can get started. Anybody else have anything that you would like to bring it up to set your expectations? So then it's time to get started with the session. By the way, welcome to you, Thara, for the session. And thanks a lot for making your time and delivering the session for today. So over to you to deliver the session, and over to you, everybody here in the session as well. Thank you.
Thank you, sir. Good evening, all. Welcome to Overview of CAE Industry. Myself, Tara, I'm working as a senior FEA engineer at Decibels. In today's session...
Yes, sir, I think we can get started with the session.
Hello, am I audible, sir?
Yes, you're audible. Please continue.
Am I audible?
Yes, you're audible.
Yeah, thank you. Once again, I welcome back to the session. In today's webinar, we are going to discuss about the CAE industry. What is in CAE industry and what are the pros and cons by this industry, and why it is like we already having a design team or the design industry, but why the CAE industry is necessary, and what are the things that the like beginner will do in the CAE industry, and applications of the CAE industry, like where and all the CAE industry is the applications what we are using, and what are the different softwares that are in the market, and so these things we'll discuss in the today's webinar. So this is the market overview of the CAE industry. Here I'm projecting from the 2015 to 2023. You can see the graph where, so every year the graph is increasing. It means CAE industry is occupying all the way. Earlier it used to be only for the vehicle, that is only for the automotive section. Now it has been increased to the domestic level also. Even for the electronics, for the television side, or other domestic purpose also, we are using the CAE industry. So in the next years, it may occupy the other sections also and it is one of the major software that we are using for the simulation purpose. Even though if it is in small design also, the CAE is going to mandatory in the next years. And what are the different softwares which are available in the CAE industry are, say for example, finite element analysis and multibody dynamics, durability, optimization, and these are the different softwares which came up in the CAE industry. So by looking at this graph, we can judge, okay, from actually before the 2015 only the industry has came up, but here I have taken only the graph. Okay, here I have chosen only from the 2015 I have taken to 23. For the next projections also, we can see how, where and all CAE is going to occupy. And here the major area, globally I'm showcasing here. This is the major area, North America, Europe, and Asia, where you can see they are using, they are implementing the CAE for all the purpose. And this is one of the North America has given a like graphs from 2018 to 2028 they have given, and here they are using in the CAE industry in the market on premises also they are using, and the cloud also. On premises in the sense inside the industry only, that is inside the company only they are doing the CAE. In the cloud means we know we are outsourcing the project, or it is a different part. most of the CAE projects will be doing in the on-premises only. Why? Because of the data security and for the design purpose and the simulation results. So on these purpose, the CAE things are going on the premises only. We are going to do. Next, what are the major tools which we use for the CAE? The major tools are Hexagon, Altair Engineering, and Dassault System, Beta CAE Systems, Autodesk, and these are the different major players in the CAE tool. And we are interested in doing the Altair Engineering. We already know Altair is one of the company who is giving the major CAE tools, starting from the finite element analysis to the optimization level also. So for example, for the Hypermesh and the Hyperview, Radios, OptiStruct, these are the important CAE tools which are running in the market. And what are the different types of CAE tools? Like in which area the CAE is going to implement? See, first we are going with the finite element analysis. We know what is a finite element analysis and why it is required. And the CFD analysis. CFD is meant for thermal analysis, where we are going to do some CFD analysis. Then the multi-boundary dynamics based on the kinematics, and analysis tool for process simulation for the manufacturing analysis, and optimization of the simulation. In earlier days, only the design was there. Then it came up with the CAE. Now it is in the optimization state. So these are the different categories of CAE industry. But basically, for all these, we need to go with the finite elements only. For all these simulations or analysis, the finite element is the base things for all. Next, what are based on the application where we can implement the CAE. In the last decades and all, we are implementing only for the automotive sectors, for the cars or any heavy vehicles. Only for these sections it was implemented. But now we can implement for the aerospace also, defense, electronics, in the medical device. It is implemented in the dentist. For the dental case also we have implemented, or if any instruments which we require for the medical purpose, for any measuring gauges or any equipments for the thermal devices also, it is implemented in the medical section. And the industrial equipments for the heavy vehicles or any machinery parts, to know what is the vibration levels, or to know what is the thermal range or heat exchange, which we need to know when we are running in any industry. And the consumer goods, as I said, consumer goods may be household things also. Say for example, washing machine, mobiles also, we are doing the CAE analysis, like drop test, crash test. And for the television also we are doing. So and it occupies in the other sections also. So these are the important area where the CAE is occupied. Next, what are the benefits of the CAE? So we already know like why CAE industry is came up. These are the important benefits by using an CAE. First one comes with the prototype testing, reduced engineering efficiency, optimized design, visualization increases, and the design cycle reduces. First, I'll go with the visualization increases. What is a visualization increases means? See, when we are doing physical prototypes and all, we may not get the accurate results. Or for doing a visualization result, we may require number of prototype testing will be required, and that will take more cost also. So these are the things. But using an CAE, you can do any type of, if you want to do analysis for the different kinds of materials, you can do it, so that you can visualize the results very closely between the different materials. And if you want to review the results or visualize the results by changing any property details also, you can do it. And design cycle reduces, obviously. So if the things are going to do just in the CAE by changing the material details, property details, and if any load details also, say for example, first I need to apply the load of 10 kg. Next, for the further cases, if you want to do it for 30 kg or 50 kg or whatever it is, you can do it in the software itself instead of do it in a physical test. So these are the important benefits. And optimized design. By using an CAE, we will get an optimized design means, okay, that the end of the product, the end of the results, what I am going to see in the CAE software, that will go for the production. That is an optimized design. You can believe that product, you can believe that results. Okay, you have tested all the cases by for the different category of the CAE conditions, so that you will get an optimized design using an CAE software. Next, by taking in one example, if you want me to tell, means prototype testing. Here I have given a simple example. This is an air wing. To design this air wing, it will take a months or years to build this to design this air wing. After designing, if you are not doing CAE, means directly if you are sending, what happens? It may fail. See, just it has designed and it is not verified whether it will take how much load or how much, like in what frequency it will fly, or what are the different loads it can take. If you are not defining, or if you are not doing in any, if you are not using any CAE tool, means we will not come to know what is the end of the results. Directly I'm taking this air wing for the prototype testing, means it may fail for the very initial load also, or it may get more deformations also in different area. See, every time I'm taking air wing, I'm applying some load or I'm applying some vibrations. So again, it will cost more, and every time I need to build the air wing physically. So to overcome this one, using an CAE software, anyhow, the designer will give all the data, the designing data he will give, material data he will give. So using all the details, I can simulate this air wing, or I can get the approximate results in the CAE software. So for example, first you has built using in some 2 mm or 3 mm thickness. Now again, if he want to change the thickness or increase or decrease the thickness, means that can be done in the CAE itself instead of going for the prototype testing. Or you can see what is the deformations and all, you can check it using a CAE tool. Okay, these are the major benefits using an CAE. For the initially the prototype testing, obviously it will cost more and all. So by using an CAE software, you can predict the results. Okay, in this area, see, in this area or this area, your component is going to fail, or what is the stress values what you are getting. You can compare the values with the yield value and ultimate value, you can compare. Okay, by looking at the values what you got in the CAE, what you got in the CAE software, you can compare the results with the actual testing also, what the stress values you are getting, and you can do some hand calculation for the same problem using the same boundary conditions, or any, or what are the loads, what you are applying using in CAE softwares. You can do the hand calculation for the same problem and compare the results between what you have got in the hand calculations and what you have done in the CAE software. Both will be having similar results. If not the exact values, you will get a similar results or approximate results close to the hand calculations. So this is the main reason why we use the CAE industry. Next, the efficiency. So obviously, as we have seen in the last slide, we can decrease the prototype testing, means obviously we are towards the efficiency and increasing the reducing the number of prototypes and increasing. You can give after doing some simulation and all, you can give your thoughts for the design engineer. Okay, this is the material what you are using, it is going to these are the effects you will get. You can show some the if any strain values, and you can show some stress values. This is the area where the component this is the area where the assembly of the component is going to deform more. So you can work on the things. Obviously the efficiency is going to increase. And in the CAE using in CAE, say in the earlier days and all, we were not doing any CAE, just it will go for the physical test. But using in CAE, you can do some fine tuning before it go for the manufacturing or before it go for the production side. So just now I have said, you can test for the different load cases, you can test for the different material properties, you can test for the different boundary conditions also. See, somewhere you want to fix for the component say for example, you want to fix the floor for the car. Just imagine you want to fix it in a 30 boundary conditions. Sometimes what happen, somebody will tell, okay, the 30 constraints what you are doing, the component is going to more stiffer and all. So you can change the boundary condition, use it within the CAE tool itself, instead of going for manufacturing and testing for the physical testing. whatever the different loads or boundary condition, material property details, are even for the, if any design changes, you can suggest for the design team. Design changes means somewhere it may be taking high stress values. When we are comparing with the yield, it may be crossing the yield value, so that you can suggest for the design team. So all these things, all these fine tuning will be done in the CAE's tool itself. So once everything is done, it will go for the build, then it will come for the physical test. Obviously, it will save the manpower, it will save the money, and first of all, it will save the time. So using an CAE software, the efficiency of the product, efficiency of the other things will be increased. Next is, what is the role of a CAE engineer? So far we have discussed what is an CAE industries and advantages of the CAE industry. Next comes to the, what is the role of the CAE engineer? So basically, the CAE engineer will not going to design any CAD models. He is not going to design anything. He will work on the product, or he will work on the components which is already designed by the design engineer. So what he is going to do? First, he will plan for the component. Just example I'm telling. You have just assume you are enrolled for some company. They have assigned you some components, some door components, floor component, or any other component you have assigned. First, you need to plan, okay, how we are going to mesh it, or how we are going to analyze the component. So for example, you are having one square box, means you need to think, okay, for this square box, do I need to go with the 2D machine or 3D machine, or do I need to extract the mid surface for this? Or you need to plan, okay, what are the critical area of this component? What are the things I should be take care before starting the machine? So first you need to plan, then the product design. So as I said, the designer will be giving the product details and all, the design data, everything he will be given. So for example, measurements he will give, thickness he will give, the material details he will give. So you need to design, it. Then the simulation. Simulation in a sense, after meshing and all, you need to apply the boundary conditions, loads given by the designer, and you need to run the file. Running the file, we are having a different solvers like OptiStruct, Radios, LS-Dyna, Abacus, Nastron. These are the different simulation software. Simulation in the sense, that is a processing part. Like after building any model, you need to run in a, you need one platform to run it. That is a simulation. Then the optimization in the sense, after designing the product and after analyzing the product, some area which is not, again I'm taking one square box. To design one square box, I can do it in a, instead of taking the sharp corners, I can go with some curved corners, so that it can take more load instead of the sharp corners. So you need end of all, you need to give some optimized design. See, something they have given you and you need to work on the things. After simulation also, you need to do the optimization, whether it is a shape optimization or size optimization. So you need to work on this optimization thing. Then the post planning. After optimization also, you need to do some post planning. Post planning in the sense, when we are doing only the one single test, we should think beyond the test also. So for example, you are doing some durability test and you are optimizing the product and you are giving the results. But in the other way also, you need to think, okay, how it works when it is in the crash test also. So these are the different things that the CAE engineer is going to do. First, it comes with the planning to the post planning. He has to think and he has to work on the model or the components, what he gets. Next is, what is the, see, in the, just I have explained what he's going to do from end to end I have given. But what are the basic things he should know? What are the basic things he should know before he start any project? First, he start with the meshing. The meshing tool is for Hypermesh. Hypermesh is one of the very good, Hypermesh is one of the major tool which most of the companies are using for the meshing purpose. That is meshing, that where we are going to do the 2D meshing, 3D meshing, or 1D meshing also using in Hypermesh tool. Then applying the boundary condition in the sense where you are going to fix the component or where we are going to mount the component. This is the boundary condition. Then the finite element analysis, that is what kind of analysis you are going to do, whether you are going to do OptiStruct, that is durability analysis, or crash analysis, then you need to run it, solution, and then the results. So after running any file, obviously you will get some details of the results. After running the file, you need to check the results. In the results, what you are going to check? So we need to validate. Okay, something I got. I have ran one file and I have received some different results file. Now I need to validate the results, or I need to check the results. So how you will check? For check the results or validating the results, some other softwares are there. Say for example, Hyperview or Hypergraph. These are the tools which we can visualize the results. Visualizing the results in the sense, okay, in the hand calculation or by looking at the some component, we can predict the results. Say for example, by looking at this track, I can predict, okay, here I may get the stress values and I need to get the stress values here. Why? Because here it is taking more load. So in such a way that I need to validate the results, what the software has given, well, what the software has given the values that are correct or not. How you can compare? So you need to compare with the conditions what you have defined in the hypermesh. That whether it may be a load condition or the material details or even the boundary conditions also. Based on these results, you need to validate in a different software the what you have done, the work is correct or not. So whether it is if it is a correct or not, you are going to report. What you are going to report? We are going to report the stress values, we are going to report the displacement values, we are going to report the frequency values, the eigenvalues we are going to report, strain values also we are going to report. And all these, the values what you are going to report, everything is based on the requirement of the project. What the project you are going to, what you are going to do, based on these things, the reportings also will change. So reporting in a sense, okay, just randomly, it is not like taking some values and keeping it in an Excel sheet or any report format. No, before reporting, you need to validate it. Whether, see, here you are applying some load and you here in the red section, you are getting the stress, means obviously there is some reasons. So you go back to the software, that is you go back to the hypermesh and you need to validate what went wrong or how you can correct it, or really the software is showing these values. So these are the steps that the CAE engineers has to think in such a way that what the designer has designed, whether it is a correct or not, he is going to validate it. So the CAE engineer is having he should give the more importance when he is doing the meshing and analyzing the component. If he is giving any wrong values, or if he is showcasing any other stress reason which is not taking the load, the designer is going to change the design, and again it may be a problem after it manufacturing. So when you are reporting or when we are validating the results, it is very important to check practically also. Sorry, you need to analyze the things. Okay, where I'm fixing the model, where the stress is coming, whether the stress values are correct or not. So these are the very important things that the engineer has to think. Why? Because based on your results, the designer is going to finalize the product. Then it will go for the manufacturing. Obviously we know after the manufacturing and all, it will come for the component level, assembly level, and for the deliverables also. After the deliverables and all, if you get, if it is fails in the market, it will come for the design engineer. So CAE engineer is having a more responsibilities to do the simulations. Next is, what are the job roles in the current market? See, once you're done with any of the CAE softwares or any CAE tools, you may get opportunities like FE modeling or meshing engineer, where we are going to mesh the component. See, basically, when we join for any industry as an entry level, definitely you are going to mesh for 1 or 2 years. Why? Because when you are meshing only, you will understand the component. See, directly I'm going for doing some simulation and all. Okay, I have one company has hired me, they put me for the simulation and all. You may not know what are the important things or what are the minor features that the car having. See, what the simulation or the what the person is who is going to do when he is having a more than 5-6 years, means just he will take the assembly stuff like this, any car assembly or door assembly. So just he will go with the assemblies and he will put some load cases, he will put the boundary conditions, and then he will start analyzing the component. But when we are working as a meshing engineer, when you start meshing, no, From the small component, you will start meshing. Okay, you will analyze the component. Okay, for the simple component only, these are the holes it is having. Okay, what is the diameter of the hole? You will get to know. What are the ribs it is having, and what are the different features that the component is having. I would suggest, whether you are going for the big company or the small company, it is good to start your career with the machine only, so that you will be familiar with the component level itself. Once you are familiar with the component level means, okay, you can imagine, okay, for any of the assembly, for the floor assembly, there are 100 components are coming, and you are familiar, okay, what are the major components in the floor, and what is the thickness of that, you will understand, and what is the critical area in the floor. So when you are in the entry level, or when you are in the modeling, definitely you will understand the concept of design, why he has designed, or why he has kept one rib over here. So all the things you will get to know only when you are doing meshing. Then in the design engineer, application engineer, these are the different names based on the company what you're going to join. Somebody has called it as a CA engineer, analyst. So all these will work based on the company only. It is not like, okay, somebody may call it as an application engineer when we are using any CAE software. So obviously the application engineer, structural analysis engineer, and the product design engineer, and the project engineer also they may call. Next is, what is the industry is expecting from a CAE engineer? Okay, you have done CAE, you have done some CAE course, or you have learned the CAE course. So while once you join for the company, what is the industry is expecting from an employee? As I said, based on the validations and the reports of the CAE engineer, the designing team is going to push the data for the manufacturing. So industry is expecting so much high level of responsibilities from the CAE team. See, perform a complex design analysis using computer-aided engineering. It means, see, for an entry level, as I said, you may work with a 10 or 20 levels of component or small sub-assemblies like that. But once you experience, you are going to work in the complex assemblies. Complex assemblies in the sense interior panel, where we can call it as a dash panel also, and light assembly, headlight assembly, tail light assembly. So these are the important and the crucial assemblies in the automotive parts. So you need to perform the design and analyze. Analyzing in the sense, you may need to do some dynamic analysis also, where the time and the load come into pictures. So these are the important complex things you need to do. Understand the customer basic requirement and the expectations. So when you are going to design, when you are going to mesh some component, first of all, you need to understand the requirement. Understand the requirement in the sense, see, I have taken this box. Just randomly, okay, I'm going to mesh in this area, and all randomly, it is not possible like that. So you need to understand the requirement in the sense, whether he is looking for the durability analysis, or any crash analysis he is looking, or any drop test. So all these things you need to understand the requirement. Then the expectations for the new product. See, expectation in the sense, you have designed you have meshed some soft component, and you have designed the data, and you are having some simulation results with you. So you need to deliver the results. Okay, this is the area where it is going to affect the component, or this is the area which is going to affect the car. So you need to give the design analyzed data for the product team, so that they can improve the design, by adding or removing in ribs, or by changing the thickness, or giving the more stiffness of the any of the changing the material properties like density, Young's modulus, or things like that, or by taking the higher grade material. So these are the important ideas or suggestions you need to give. Based on your validation reports only, the design team is going to take for the next step. Developing engineering designs with a minimal supervision. See, once you join for any company, nobody is going to sit behind you and explain all the things. So you need to develop the engineering skills. Say, for example, the next person is sitting next to me, he is taking 3 hours to mesh the component. So obviously you need to take less than that. So nobody is going to no one will sit together to they will not tell you from A to Z, okay, this is how you need to mesh, this is the way you are not improvements is required and all, they will not tell all these things. You need to do minimal supervision means, okay, here some critical area section is there, how you can mesh that, or how the better quality of the mesh you can give, and the quality of the elements what you are carrying. See, in the critical area, what the beginners will do, no, just randomly they will keep the elements which is failing for the quality. So for in that time and all, so you need to do the mesh in a very good way by giving the good quality of the elements. Experience in meshing software. See, first day you are taking a 10 hours to do one component means, down the line for the next 4 to 5 months or next in some more months, you need to do it in a 5 hours. Why? Because the company will expect you to do that. For the beginners, they will give a chance to get experience with the component, or they may give you more time to work with the components. But once you having few months or few years of experience, obviously their expectation levels will be different. Maintain all the records and activities of the results. As I said, the results are very important. The CAE results are very important, and all the activities. Activities in the sense, today you have done the machine using in 5 mm of elements, and somebody tomorrow's the project requirement will be different. They may ask you to work on the 10 mm also. So if you are having a data of 5 to 10 means, obviously you can give whichever based on the requirement, you can give the meshed component. So for the sum analysis, the 5 mm is required. For some other analysis, it may require the 10 mm mesh also. So you need to keep all the records, and moreover, all the time, most of the time, we are going to mesh the, we are going to simulation, we are going to do the analysis on the existing components only. So when you are maintaining all the records, definitely it is going to work in the next upcoming days. Why? Because today you have designed something and you have sent the results, and what if it is come back to the updation of the design? Okay, the designer has updated something here, or he has updated, instead of the sharp corners, he had put some round corners, or he has taken his part away, or he has added more extra rib for this section and all. Again, it will just come for the updation. This is not a new design, just an updation. If you are tracking the results, or if you are keeping the old results means, you can use the existing measure instead of doing from the starting. So these are the useful tips. I can tell this is one of the useful tip for an CAE engineer. And you whether you join any big company or small company, but the industry expecting more from a CAE engineer. Why? Because as I see, I'm stressing again and again, based on our results only, the design, then part is going to design it or not. So these are the major companies, that Altair, Siemens, where they are taking the CAE engineers, and these are the leads. These are the major company which are leading the market. ANSYS, Hexagon, Autodesk, where they are hiring the CAE engineer from the basic and the entry level also. They are taking the engineers. And TCS, HCL, Quest, Tech Mahindra, Altron, L&T, and few companies, they are manufacturing the components in their premises only. And the TCS is the supplier where they are going to supply for the General Motors, and Tech Mahindra, they are having their own manufacturing company. So Ola Electric, now it is one of the leading electric vehicle company. They are having their own production house, and the Mercedes Benz, and one of the OEM which is the leading in the market. These are the different companies where you can get the career opportunities. So they will take the engineer from the starting itself. If you know, if you are good at any of the CAE tool, or if you have done any of the CAE courses means, and you are good at your academics, and if you are capable to pass the interview and all, definitely you will get in placements in these different companies. And I hope I have given a overview of what is in CAE industries, and what are the companies, what are the different things that the CAE engineer is going to handle once he joined for the industry and all. I hope I have given enough knowledge in this tool. And going with this, Vinayak,
Yeah.
are you going to take?
Yeah, sure.
Yeah. In Decibels, we are having some course that is the master certification course in Automotive CAE, where you are going to learn the hypermesh tool. That is from the pre-processing part you are going to learn. And with that, we are going to teach the simulations also. That is the using an OptiStruct and the radios. You are going to teach some static analysis, model analysis, and using the radios also. We are going to teach some simulation case studies. Along with that, we are teaching the post-processing part, how to use the hyperview and the hypergraph. For, as I said, for the reporting and the validation purpose. All these things are available in the master courses or master course. That is, the Decibels is offering this course. My colleague will take next. He will continue this part.
Sure. Thank you, Tara. Thank you for the session, and I'll take it from here. Good evening, guys. Hope you guys gained few knowledge about the CAE industry. I'll just take a few more minutes of your time to explain the further things like what we provide from Decibels Lab, which will benefit you for building a career in CAE industry. Tara, can you stop sharing the screen, please?
Yeah.
Yeah, thank you. We do provide courses for. Is my screen visible?
Yeah, it is visible, Vinayak.
Yeah, okay. Thank you. So I'll be sharing the link with you guys. These are just a second. Here we do provide master courses. This is a 9 months course, which will be 100% placement guaranteed or free refund course. This is suitable for mechanical and automobile engineering students. Sorry. Who have completed their engineering recently, or maybe a 1 year or 2 year gap if they have. These are the modules. You can explore it. I'll just give you the links. I'll be sharing the links in the chat box. Please find the links there. And we do have this is a 9 months course, and we do have a micro specialization course, which will be a 3 months course, which can give you insights on make you specialized in few topics of CAE. I'll be giving this. We'll take the questions in a bit. That I will take over the session in a bit. Okay.
Yeah.
We do provide a few sessions. I mean the micro specialization. This is a 3 months course. You can go through the web page to find more information regarding this. I won't be taking your time too much. Then coming to your certificate, I'll do one thing. Tara, please take the questions. Later, I'll explain them how to generate the certificate.
Okay. Arjun is asking, is this useful for aerospace engineering? Yes, it is very useful. It is very useful for the aerospace engineers also, where in the aero domain also, CA is acquired a lot of the space.
There are few more questions. Please take it in the chat box. Some have.
Okay. Somebody is asking stress engineers. Yeah, in few companies they call it as a stress engineer also. Conclusion of the webinar: we will join the industry analysis, pre-design the product. See, pre-design, you are not going to pre-design. You are going to take the component which is already designed. You are going to give the updation on the design. Product specification and so on and all, we are not giving the product specification. The specification is the different part. We can give the flexible ideas for the design engineers, what he can do the better things in the while designing the part. What is the scope of CAE? Packing machinery industries. Sorry, I don't have much idea in the packing machinery industries, but obviously in the machinery side, it is very important where we are going to see some machines will run for 24/7. They will run. So based on that, they are doing some simulations. Say for example, thermal analysis. They may do that how much heat it is dissipating. So these things will be done for the packaging industries also. What will be the salary for the engineer? See, the salary for the engineers is based on your performance when you are taking the interview, and for an entry level, they may start from 3.5 to, depends on the company where you are going to join. Some of the OEMs, they may give up to 6 lakhs, they will give. Aeronautical students, see, specifically, it is not like we are nowhere we are mentioning only for it is for the mechanical or aerospace or aeronautical. It is not like that. You can take this course even though you are an aeronautical engineering. Why? Because the subjects what we are going to learn, it may be, see, in a semester you are going to take the 10 subjects, means obviously we will be having a 4 similar subjects. So that is the theory behind the mechanical engineering. The same subject what you are going to learn, it may be 2 or 3 subjects only different, but the FEA, as I said, FEM, finite element analysis, is for aeronautical also we will use, aerospace also we will use in all the categories. You can, for aeronautical also it will be useful. See, yes, there are a lot many softwares which are available in the market. How you can decide? You can ask your colleagues or you can ask your seniors, okay, where they are working, what are the softwares they are using. As I said, I'm telling Hypermesh. Yeah, obviously, the Mercedes using Hypermesh, TCS is using Hypermesh, and Tech Mahindra is using Hypermesh. So these are the leading companies in the market. They are using Hypermesh. So obviously, you can, based on these graph also you can decide. Yes, it is useful for aeronautical engineering. Ma'am, I'm a little confusing between the ANSYS and the Hypermesh software. Please tell us the future scope of this. Which one would be better? Okay, ANSYS and the Hypermesh. In ANSYS, you will build the model and you will analyze it. But Hypermesh, it is a pre-processing tool. That means the Hypermesh is majorly we are using for meshing. That is whatever crash test, drop test. See, just you assume, okay, durability test. So you need to do something. Okay, you need to analyze something. But before analyzing, what you need to prepare some data, no? So that data, what we are doing in the Hypermesh. Hypermesh is a pre-processing tool, whereas ANSYS is post-processing. Okay, in that ANSYS we'll do pre-processing and post-processing also we'll do, but Hypermesh is specifically meant for machine, that is the pre-processing. See, you cannot decide anything. Okay, crash team. Okay, Prashant is asking. Sorry, I forgot to take the names. I'll just go with this. Prashant is asking. Okay, should go for crash field and durability field. Durability field. No, it is not like that. For single car, we are doing drop test, crash test, durability test, noise vibration test. So we'll do all the tests. First, the company, when you join for the company, no, there are the different teams will be there. No such feel like, okay, this company is doing only for the crash, or okay, this company is doing only for the durability. No, it is not like that. The company, based on the project, see, one company is taking different simulation projects. Crash, durability are different things. But when you go inside the company, they will choose you for the different teams. Okay, I think I have answered all the questions. Okay, Hypermesh is pre-processing, but the solving, which is the solve. Dyna radius, ANSYS workbench. Yeah. Yes, you can learn now. The radius is in the trending. That is the more majorly occupied solver. And for Dyna, for crash analysis, I can suggest Dyna and the radius. These are the very good softwares for dynamic or non-linear cases. If others having any other doubts related to the CAE industry, they can ask. As for the structural analysis, yeah, they can become if and only if they know the tool. CFT, see, there also I'm using the finite element analysis. See, the term, the finite element analysis will applicable for all the simulation. Next comes to the what kind of elements you are using. or what kind of the platform you are using. I'm using Hypermesh for this platform, but I'm using CFD for thermal analysis. So finite element analysis only, but the different platforms. In the future scope of, yes, Hypermesh, you can choose the Hypermesh. Is one of the good software that is from the past decades. We are using the Hypermesh, and it is having a future scope also. For analysis purpose, yeah, I said radios, OptiStruct, and optimization tools also there. Strength of materials you need to learn. That is okay. Strength of materials you have mentioned. Thermodynamics, vibrations, heat and mass transfer, and some knowledge in the material and the material science. Why? Because everything what we are going to do, it's all depends on the material, the quality of the material, and the Young's modulus, the graph, stress strain. So based on these only, we are going to learn. And Abacus softwares, we will let you know in the further sessions. We will let you know when we can take the Abacus software. Yeah, like if you want to become an analyst, obviously you will be knowing you need to learn some the solvers, that may be the radios or LS Dyna. You need to learn for Prashant. Or else the current company what you are working, you can approach for your seniors or your team asking, okay, I would like to learn the solver tool. So by asking that also, or by sitting next to the person who is doing the simulation, you can ask them. That is also a possible way. That's the easiest way I can tell.
Any more questions? Okay, I think there are no more questions. Till then, I'll just share. I've just shared you a link to generate your certificate. That is 2 minutes. I'll just explain them.
Okay.
I hope everybody can see my screen. Just have to click the link which I've just shared in the chat box. You'll end up here. Just click on the enroll for free button, and then if you are already logged in, you'll be landing up here, or else you'll be asked to log in with your registered mail ID. So please register, log in with your registered mail ID. Then you'll be here. I'm just explaining you how to generate your certificates. Okay. So just before generating your certificates, please go and check your name through the accounts. If there are any fields left to be filled in creating the profile, please complete those fields, and then come back here. Use the same link again. Same, click on the enroll button, and then you'll land up here. You can just have to go click on continue, and here what you have explained. What is the importance to share the certificates in your LinkedIn profile, since it's a professional platform, how it will be helpful. Those things we have explained here, and then click on continue, and you'll be popped up a message, a dialog box. On that, it will be a link called get your certificate. Click on that and you'll get your certificate, digital certificate like this. You can just download and keep it as a PDF. You can copy paste and save the link somewhere. And you can also share in LinkedIn, Facebook, or Twitter. If you do share it on any social media platform, please do tag us. Okay. And later this part, I'll be sharing you a link for the feedback. Please give us your valuable feedback. It will help us to grow and bring new topics which will be helpful for you. And I'll be sharing the community link of Decibels Lab. It's an EV community link. If you are interested, you can join using that link. Okay. Tara, please continue if you have received any questions.
Questions I have not received any yet.
Okay.
But the course what the Decibels is offering, it is a 100% placement course, and already we have placed a few students, few got placed in the Bangalore, and few got placed in the Chennai, and they are working for the Ford also. So anybody wants to learn this tool or anybody wants to explore the career in the CA industry, you can contact us, and I will be the mentor for this course. So like you can once you join for the course, you will get to know what are the things to be done for the machine side also, on the simulation side also, and it is a 100% placement guaranteed course. For any other further details, you can contact the Decibels. And thanks for joining the course. Sorry, thanks for joining the webinar.